Hello, welcome to episode 3 of the How to Make Grow a Garden in Roblox series. In this episode, we'll be making plants grow.
We're going to go into plant handover again, and we're going to write a really big function. Function plant handover dot initialize plant player. So plant folder config plant circle local circle pose equals plant circle dot position. Call this circle position. Local plant CF, so the C frame equals C frame dot new circle position times C frame dot angles 0 math dot rad math dot random negative 180 comma 180 0 local plant scale equals math.random config dot min scale times 100. This is just so we can have like multiple decimal places, because math.random only works in whole numbers. So if we had, let's say, like in mine, I have, I believe, 0.65. Yeah, that would not work. Even if we multiplied it by 10, that'd be 6.5, so you wouldn't get all those. So we're going to multiply it by 100, and then we're just going to divide it all by 100. So now I'm going to, in the next one, go config max scale times 100, and then just divide it by 100. And we need to get the first plot, and we're going to make a function to determine the mutation, but we're not actually doing that yet. It's just going to give us the standard one for now. So local plot equals plot handover get plot player local mutation, and now I need another function. So local local function determine mutation plant folder, just going to do that. We're just going to return normal so we can get this normal one just for testing right now. Mutations will be in a future video. Mutation equals determine mutation. We don't even need to put anything. And I guess I can put the plant folder. If plant folder find first child mutation, then plant folder equals this right here. Else return nil. Next, we're going to get the stages. So we're going to get the children of that plant folder that we just set. We'll go plant stages equals plant folder. Go and get children. Now we need to sort it. So a stage value that we put inside of each one of these, we're going to sort them by that so we can get them in order. So now we're going to do table dot sort plant stages function A, comma B, and A and B are just two of the things. We're just going to return if one should be put before the other. We'll go A value equals A find first child stage dot value B value equals B. I'm just going to copy paste this. Return A value less than B value. Equal time per stage equals config dot grow time divided by, in parentheses, number of plant stages plus 1. The reason we're adding 1 is because I'm counting that little circle as a stage so it doesn't immediately go away. Local is full grown equals false. That's not false. False. Local current stage equals 0. Local plant equals nil. Now we're going to get the final stage, and we're basically going to make that final stage, which is the fully grown plant, we're going to make it right now and just make it invisible. basically, we're doing that so we can store it in the table, so we can store the time, so that when we eventually add like saving of data and offline growing, it'll be ready for that. Vocal final stage equals plant stages, number, in square brackets, number of plant stages, so it's just the last one. Then we're gonna clone it. Final stage dot parent equals plot dot plants. Final stage colon pivot to plant CF plant C frame. That's pretty good. Now we need one more function to randomize the scale, and that function is going to be called scale model. Local function scale model scale. We're going to get the primary part of the model. So that's one thing with these models. You're going to need to set the primary part. I recommend always setting it to the base part. So in this case of stage 1, it's going to be this bottom one. You can see this one's lower. I'm going to set the primary part to this lower one. And I'm going to do the same thing for the other ones. Now that those are all set, we can go into plant handover, and local primary equals model dot primary part. If primary, then, well, no, if not primary, then return. Local original C frame, original CF equals primary dot C frame. Now you do for underscore comma part in pairs model. Go and get descendants if part one is a part, then local offset equals primary dot C frame going to object space part dot C frame, and new offset is going to equal C frame dot new offset dot position times scale times offset dot rotation. Now part dot size times equals scale, and part dot C frame equals original C frame times new offset. And that is that function done. Now in here we're going to scale model final stage plant scale. Now for underscore comma part in pairs final stage colon get descendants do if part colon is a part, then local default transparency equals part dot transparency. Local default can collide equals part dot can collide. This is just saving it, so if it had can collide off, it will end up with can collide off again, rather than just having everything be fully opaque and can collide on. Now I'm going to add a table here. Local final stage parts equals a table. Final stage parts part equals a table, and final stage parts part dot transparency equals default transparency. Final stage parts part dot can collide equals default can collide. Next, we are going to set part dot can query to false, part dot transparency to 1, and part dot can provide to false. Below this, I'm gonna put if not plant handover plants player, then plant handover dot plants player equals an empty table. Plant handler dot plants player final stage equals empty table. Then plant handler dot plants player final stage dot grow start time equals start time. This is for the start time, so we can calculate other times just to save it as well, so we can have offline growing. We're going to make a loop, at least temporarily. May replace the way this works in the future. For now, this will work just fine. So I'm going to task.spawn function while not is full grown, do task.wait time per stage. If current stage is less than the number is less than number of plant stages, then current stage plus equals 1. If plant circle, then plant circle colon destroy. If current stage equals number of plant stages, then is full grown equals true. And now we're gonna go grab this right here, and we're gonna copy it and put it right down here. And we're gonna delete these. I'm gonna delete these. And delete that. I'm going to set can query to true. Basically, the can query being set to false makes it so that we can still place things next to the plant before it grows, because it won't detect it being in the way. But if you have this set to true, you won't be able to place it to where it would intersect, which is helpful if you don't want it to after it's fully grown. Although it will prevent the second one from doing so. Can query equals true. Part currency, I'm gonna set it equal to this. Part.can provide, I'm gonna set it equal to that. Actually, that is. No, we're gonna go if final stage parts part, then I'm going to do this. And up here, yeah, cool. Now that should be working. Right here, I'm gonna put an else. Plant equals plant stages current stage clone plant dot parent equals plot find first child plants plant pivot to plant cf times cframe dot new. So this is just going to put it at the C-frame we specified before, but we're going to change it slightly so it's not in the ground. In the C-frame we're going to put 0, then plant, primary part, dot size, dot y divided by 2, then another comma 0. Just need to scale it, so scale model. Plant plant scale. And now that should be everything. So what we're going to do is go into plant seed at the end here. After this, if new circle dot parent, then plant handover dot initialize plant player plant folder config plant plant config position, and that should be it. Sorry, we're not doing that. We're looking at we look up here. We need the player, plant folder, config, and the plant circle. So not position, new circle. Now, if I plant a carrot, it should grow. Now it is off the ground. That's just because of the way I have it. I can fix that, but now we have growing plants. And we can teleport to our plot. They vary in size and rotation based on what you set for the size, and rotation is just random. Now, if you want to adjust where they sit, you can either, for ones that's supposed to be in the ground, you can just change the primary part, or you can adjust the pivot point. I just changed the primary part if I were you. So, let me just, you can bring it right here, and you can select the primary part, and you can just select it, primary part, select it, primary part, select it. Now I put it back into the carrot folder, the normal folder. It should hopefully be in the ground. And if not, you can mess with it. And if you really want, you could put a different part that's transparent inside of it and make that the primary part, just to position it properly. That's what I might do. Let's say I wanted these to be deeper in the ground. I can duplicate this part, and I can shrink it. I can make it transparent, and I'm just going to call it main. And now I'm going to set the primary part to main. I need the same thing for all of these. Now if I put them back in there, they should be a little deeper under the ground. For fixing that, plants that you want on the ground, it doesn't really matter, as long as you set the base, the bottom part, to be the primary part, the one that's touching the ground. And look at that. Now we've got some carrots. And you can add other plants in the same way. Actually, let me just add a potato or something. Now I made the config for it, I have it in the folder, and now I just need to make a seed. I forgot a part. Right here, where we have destroy the circle. Right here. If plant, then plant, destroy. Now we won't have that Z fighting issue. There we go. That's better. Thank you so much for watching. Next episode will be about harvesting and maybe selling crops.